Hi, good morning, everyone. So today we are going to have a discussion on auto cycle let's try session and also the tutorial. So before you start watching this video, I hope you have tried at home by yourself so that you know clearly what's wrong with your calculation. We are learning together. So if there is some mistake or there is some silly mistake or anything, just feel free to let me know. Is that all right? So some of you might question, okay, my answer is, for example, 54. I give you the answer is 54%, but your calculation coming out is 53.8 or 53.5%, which is, I would say, is acceptable. I'll more focus on the calculation rather than the step rather than just the answer. Normally, when I do the marking, I'm not just looking at the answer, but the step. So make sure you write your SI unit and you write all the step clearly. So at least I can give you some marks on this. So let's try session and tutorial so that we can, when you get used with it, when we have quiz or test, it'll be easier for you. So let's have a look. Yeah. So for the let's try auto cycle, calculate the compression ratio. Okay, we know compression ratio is RV equals to V1 over V2. What's that means? If you draw the diagram out auto cycle, okay, so this is PV diagram, 1 to 2, isentropic compression, and then constant volume Q in. And then this is number 3 to 4, isentropic expansion, and then it will go back to the original exhaust condition. This is quite simple, and you need to remember Q in is here, Q out is here. All right, so why are we V1 over V2? If you look at here, this is our VC. If you look at here, this is actually VC plus, and this point, this is our VS. So I will say V1 equals to Vs plus Vc over Vs. All right. So the question asking for the compression ratio. So the first thing is RC is given. Make sure you change everything to SI unit. That will be easier. So I will just put the equation in there. So, but we don't have the Vs yet. So the Vs is, you know, that pi r square h. The given one is the diameter, so you have to change it to radius. So 25 times. Okay. Let me check. Yeah. So it should be 3. It should be 3. It should be, well, I can write here 3.3. Let me do some changes. Okay. Okay. 7.5 times. Right. So your Vs should be 1.47 times power of -4 meter cube. So you know your Vc from here, you know your Vs from here, so you can get your answer is 7.9. Is that okay? So that's it. So I think the question is just for the compression ratio. So next, go to the, let's try 2. Auto cycle is conducted, right? The auto cycle is conducted. Yeah. So auto cycle is conducted air at 100 kilopascal and 20 Celsius. So my advice is first draw the PV diagram. Okay, so this is Otto cycle. I know that. Isentropic compression 1 to 2, and then 2 to 3, constant volume. 3 to 4, isentropic expansion. 4 to 1 is constant volume as source process. So, okay, so I know that P1 equals to 100 kilopascal. T1 equals to 20 Celsius plus 273. Change everything to SI unit, yeah? So, and then air is then heated at constant volume to 1000. So, heated at constant volume to 1500. So, I know that T3 equals to 1500 plus 273. Oh my, 273 is flying. Equals to 1773 kilopascal. What else? And then it's showing that the RV is given equals to 8. That's lots of information. So the first question is thermal efficiency. What is the thermal efficiency? So since the RV is given, that will be easier. So we try the first one first. Okay, right? The thermal efficiency equation is 1 minus RV alpha minus gamma minus 1. So 1 minus RV is 8. So normally because we are using air and we assume it's perfect air, so the gamma is 1.4. So you can have 0.565. So question number 2, the heat input per kilo of air. We know that Q equals to MC V T3 minus T2. Okay, so we know the T3. We don't know the T2. We don't know the Q in. We don't know the T2. All right. So because it's in kilo, I will say this is small Q in. CV T3 minus T2. Okay, so but we also know that 1 to 2, in order to solve this equation, we have to get a T2. 1 to 2 is isentropic, right? So we know that T1, T2 equals to 1 minus, let me see, V2, V1, alpha, gamma minus 1. Also, I can reverse it. It becomes 1 over RV minus 1. So T1 is given 293, T2. You know the RV. So therefore, your T2 is 673.13 Kelvin. Well, if your answer is 673, it's okay. There is a little bit of changes, different, that is all right. So since you have T2, right, you have T3, you have the CV, so you can get your Q in equals to 789.7 kilojoule over kg. If your T2 is a bit different, you will have a slightly different answer from me, but not until like your answer is 810. So please check your unit as well, yeah? So part 2 done. The network output of per kilo of air. So in what the network over the Q in, right? And we know the efficiency, and we know the Q in. Can we get a network? So the network is 0.565, which is the thermal efficiency times the Q in. The Q in is 789.7. So you will have 446.2 kilojoule over kg. That's it. All right. Let's move to question number 3. So an Otto cycle, the maximum and the minimum temperature are 1400 and 15 Celsius. The heat supply per kg of air is 800 kilojoule. Calculate the compression ratio. So in this part is the difference is now we are given the, and again we look at the diagram. Quickly draw the simple PV diagram for the Otto cycle. The more you practice, the easier for you to remember. So 1, this is isentropic, 2, 3, 4. Okay, and I know that this is Q in. Okay, so it's say maximum. It seems like if you draw 2 of them, TS diagram, okay. So when isentropic compression, the entropy is constant, but the temperature increasing from 1 to 2. And when it's constant volume, heat addition, heat supply, so the temperature increase and also the isentropic. So therefore you have 2 to 3 increasing. And then after that, 3 to 4 is isentropic expansion. It's isentropic, so constant entropy. So, and then it go back to the normal point, original point. So we know that the maximum temperature is actually T3, and the minimum obviously is the T1. So we know that T1 is 15 plus 273. What is the number? 288 Kelvin. T3 is 1400 plus 273 equals to 1673 Kelvin. So the Q in heat now is 800 because it's per kilo. So I would say this is okay. Let's erase it first. Okay, right. So I will say this is Q, little Q in, kilojoule over kg. Okay, so the first question is asking what is the RV? And the second question is asking about what is the efficiency? So it's quite easy. Let's try together. So we know that the first one, 1 to 2, is isentropic compression. So this is V1 over V2. It also equals to T1 over T2 equals to V1, V2 over V1. Okay, right. But the problem is we have T1, we don't have T2, we don't know about the RV. So means that we need to find the T2. And if you look at here, what we can try is the Q1, the Q in. The Q in equals to CV T3 minus T2, which is just nice because we have T3, we have the Q in, we have the CV, we can get the T2. So therefore, we have 800 here, 0.718, 1673 minus T2. So you can get your T2 is 558.8 Kelvin. And by plugging the T2 here, you can very easily get your RV equals to 1.18, roughly like that. Is that okay? So what about the efficiency? Efficiency is even easier because you know that 1 over RV gamma minus 1. So you just plug in the RV there and you should get your efficiency. I might have a little bit of silly mistake here and there. I mean, not the silly mistake, the difference between compared to your answer, but the step should be the correct one, and you might using different way to solve it. For example, you will like to find the Q out first, and then you try to solve it using the efficiency equals to Q in minus Q out over Q in. That's fine. But the difference is there will be slightly different on the answer. That is okay as well, as long as your step is showing reasonable step. All right. So let's try 4. All right. So let's try 4 is an Otto cycle. The temperature at the beginning and at the end of the isentropic compression are. So the first thing, I won't do anything. I just draw the PV diagram first. Right. So 1, 2 isentropic. Right. 2, 3 is constant volume. 3, 4 is isentropic expansion. 4, 1 is constant volume. Back to the original place, cooling. So we know that the temperature at the beginning, it seems like T1 equals to 316 Kelvin. The beginning and the end. So T2 is 596 Kelvin. So determine the air standard efficiency at the, another way is the thermal efficiency, and also the compression ratio. So what are there? How to solve that? It's not difficult, I would say. So the first one is we still need to find the what's that, the RV. So RV is equals to V1 over V2, and T1 over T2 equals to V2 over V1 gamma minus 1. Well, your question might be, hey, where I get this, guess this equation. So let me show you something, yeah? Let me show you, I hope I have it. If you look at your lecture note, right? Actually, table is given here. This is the summary. And the previous lecture, I did show you how the step to get all the information. So you can refer back them to get all the equation and understand, rather than you just memorize. But as long as you practice, soon it will go to your mind. Anyway, let's go back here. So we know the T1, we know the T2, and we know the gamma. Definitely we can get our RV. Your RV is 4.885, or you can say 5. All right. So what about the efficiency? Efficiency is very simple. 1 over RV gamma minus 1. Because you already have the equation, I use 4.885, so my answer is 4. Let's try.